See? Oh yeah. Let's see. So these explorations, they're supposed to challenge you because it's a new concept. Don't get too frustrated or shut down if you aren't getting to the exact answer. Understand, we're going to go over them, and these are just way different methods to solve the same problem. So, that's why I'm doing it. Well, check your answer. Check your answer. When you get to your answers, you should be able to check them with your partner. You should be able to get to the same ordered pair as your solutions. If you did, you both did it correct. If you didn't, it's okay. We have the lesson to go over. Different strategies of how we can sort out those mistakes. Then you'll be done, because take a look at what that'll do to you. There you go.
We both did.
Make sure you take the fast and final.
Yeah, I don't know. Hey, bud. What'd you get for sheep? It's on the board.
Thank you so much. Okay, I can have you guys. You'll have a chance to work on this some more a little bit later when we get a free moment, but I wanted to just kind of move on. And if I could have you guys return your seats, please. Everything all right over there, Jake? Don't worry about it. This beginning portion of each section is an exploration, so that way it challenges you to learn a new concept without getting the direct instruction of it. It's okay if you didn't get these as your answers. This is just a way to check to see if you kind of have a little bit of understanding already. If not, don't worry too much about it, because by the time you leave today, I have a firm belief that you guys will be all right with understanding the concepts here. So, I'll come back to you about that, Jake, if you'll have further questions, all right? So, for part A, -2, -5 would be your solution, whether you use substitution or if you felt graphing was your better way to do it, you would get this as your point of intersection as well. For part B, 1, 2, depending on, well, actually not depending on either way which method you use, you should get that as your answer. And for part C, -1, 3. Questions before we move on? Okay, so I want to touch base on the vocab for this section a little bit, along with the core concept. Question, Taylor?
No.
Okay. If you'd like, I could come on over and touch base with you a little bit later as well. You still got questions about this. But understand, they won't always be in this form. Sometimes they might be a little simpler and already put into x equals or y equals. So that way you can then plug that in quite simply. So, moving forward, if you could please turn over to page 139 in the student journal.
Oh my god. Wait, what page?
139. Okay. With this section being about similar concepts as 5.1, we're going to have similar vocab. So, system of linear equations. Austin, you care to enlighten me? What does it mean to you when you think of system of linear equations? What's your definition of that?
It's like different linear equations together that make something work.
Right, together. When you say together, what do you mean by that? How many equations specifically? Two or more, perfect. So, system of linear equations is two or more linear equations. Now, what about this solution of a system of linear equations? We saw this in the last section when we would solve by graphing. Last section, what did the solution of a system of those linear equations look like? An ordered pair, perfect. And that's what it's going to be for graphing or for substitution, along with the next method that we learn next class. So, ordered pair that makes both equations true. Questions about either of these? Much like the last section also, we had a step-by-step process of how to solve by graphing. This section, we have, again, step-by-step process, how to solve by substitution. For your note card for the quiz, along with for your cheat sheet for the final, I would highly recommend writing these 3 steps down if it's more convenient for you that way. All right? But one thing I do need you to understand though, even if you find graphing is easier than substitution, you will be asked to solve by substitution on the quiz. So you need to know how to do that, along with how to solve by graphing, along with the third method that we'll learn next class. But depending on what the instructions ask, you will definitely have to see this on the quiz. Okay? Questions before we move on? Before I show you the first example, how do you check your solution?
You just plug in your ordered pair
Plug in your ordered pair where?
to one or both equations.
One or both?
Yeah.
How about we'll go with both equations?
Okay.
So we want to make sure that to check your solution, we plug it into both equations to make sure that it is the solution of that linear system of linear equations. If you could please take out some notebook paper or those guided notes, go over some examples. Yeah, if you need some binder paper, there's plenty of binder paper over here on the shelf. Our first example that we have up here, we want to solve this system of linear equations by substitution. The first equation reads y equals negative 2x minus 9. The second one reads 6x minus 5y equals negative 19. Justin, what equation and what variable am I going to solve for? So substitute the y in. Conveniently, this one already says that y equals negative 2x minus 9. Since this y and this y are the same thing, Justin's telling us that we're going to substitute this portion of y into the second equation and solve for y. Or I'm sorry, excuse me, solve for x. That said, let's plug in negative 2x minus 9 for y. What's the next step that I have to do here, Eric?
Plug in negative 5, well, distribute negative 5 into negative 2 and negative 9.
Awesome. So we'll have 6x plus 10x plus 45 equal to negative 19. We'll combine the 6x and the 10x. We'll subtract 45 from each side. So we get 16x is equal to negative 64. Dividing both sides by 16. That x is equal to negative 4. What do I do next, Kate? I have x equals negative 4.
Then you plug that in for the first equation, plug negative 4 in for x.
Awesome. So we're going to plug it into the first equation. And is there a reason why you chose the first equation, or does it matter?
It's just easier because y itself.
Yeah, it doesn't really matter, but understanding the whole reason why Justin chose y equals negative 2x minus 9 is because it was convenience, and we already have y equals, since we have x. Let's plug that in the first equation to solve for y. So we have y is equal to negative 2 times negative 4 minus 9. 8 minus 9, and y is equal to negative 1. Combining that, we have our ordered pair of negative 4, comma negative 1. Questions? Kind of help clear some confusion maybe, Jake?
I think I'm certain good.
Okay. Maybe I'll have you come on up to example a little bit. So, questions before we move on? Yes?
So how to start the problem off, you just take away, like, whichever one you're doing first, you take away the other variable, like the other part of the order here.
So,
Like you just take it away from the entire equation.
I think I understand what you mean. You mean like how in this equation here, I don't have y present at all? Yeah, I do, because I conveniently have y equals this stuff. Since these two y's are the same, I want to plug this stuff in for this y in the second one. So then I get just x. Remember, if you have two variables in one equation, you can't really solve for it, but if you have one variable in one equation, you can get to an answer with that. That kind of, Sarah Vinley?
Will they always give you like the first equation with just like y on one side and like not have it complicated? So if you don't have it that way, then you're gonna solve to make it in that form, right?
For y or x, but yes. We'll see that with the next actual example we go into. But I'd like you to practice on your own with your partner how to solve this system of linear equation by substitution. And I think I'll have Mr. Major come on up and solve this once we've had a couple minutes. So, please solve the system of linear equations by substitution. Y equals negative x plus 3 and 3y plus 5x equals negative 1. Give it about 2 to 3 minutes and then hopefully we'll have an answer.
Okay,
So we're gonna plug the units are solved in for y.
Yes. Right here. And then plug all of it in.
Now I get it.
Yeah.
Wait, so if it's a negative x and a negative 5,
5 become a positive. Y equals positive. Nope, not positive 5x. You're replacing that x with negative 5. So negative 5. Y equals 5. That's 3. Y is 8. And take that negative 5. 8. Yeah, good job. Hey, he gets it.
I get it, you don't.
How many people do I still have working on this?
I finished and then I'll turn.
Okay, we'll give you about another 30 seconds.
There's only one problem.
No, never mind.
Are you going to So I guess if you're.
And
My mom's the same.
come on up and do this one? Sounds good?
No, it's going too well. What's the big deal about rain? You don't feel rain. This is the big deal. I have to get home somehow. No, my dad took me to you. So he picked me. He can't drive me to the
Jake, are we ready?
pretty sweet.
Come on up. If you got it wrong, yeah, feel free to bring it to work. Okay, so,
Bungie, you that's true.
Yeah, like,
let's help Mr. Major out here.
I'm gonna figure it out. Don't go to me like that.
Which equation are you gonna plug into the other equation and for which variable?
I'm gonna plug this in for y, because I already have what y equals up there.
When you say this, what do you mean this?
I'm
Do
gonna
you mean
plug,
just the negative x?
I'm gonna plug negative x plus 3 in for y.
Cool, so let's start off by doing that. We'll make parentheses.
That's good.
That's alright. Is that a 4 or a 9? Is it a 4?
Is a
Or
four.
should it
No,
be a
it should be a
9?
9. I just can't write.
It's okay. My handwriting's not the greatest either. So, what do we get as our value of x?
That's 2. 5.
Thank you. Well, are we done?
No, because we have to put it back into the other equation, right?
Perfect. So, negative of a negative. So,
Positive 5.
yeah. Keep that in mind. Even though your answer here does say x equals negative 5, understand that if you were to plug it in, you'd still have to account for this negative over here. So you'd have to make it a positive 5. Thanks.
So,
Final answer?
y, so. There we go.
Awesome. Did that kind of help out?
Yeah,
Thank you, sir.
I see what you're talking about.